The region space telescopes avoid. There's a part of the universe that humanity deliberately chooses not to look at directly, not because it is empty or unimportant, but because observing it threatens to overwhelm the very instruments designed to reveal the cosmos. It exists in plain sight, yet remains one of the least understood regions in space, hidden not by distance, but by necessity. To understand why this avoidance still matters today, we need to examine how space telescopes are designed to see. These instruments are built for sensitivity, engineered to detect the faintest signals traveling across billions of years. That precision comes with fragility, because exposure to intense radiation, glare, or unpredictable environments can permanently damage their ability to observe anything at all. Protection, in this context, requires restraint. That restraint defines this region. Near powerful sources of light, energy, and distortion, telescopes must look away, creating blind zones where data is sparse or non-existent. These areas are mapped not by what is seen, but by what cannot be safely measured, leaving gaps in understanding that persist despite advanced technology. The universe does not end at these boundaries, but observation does. What makes the situation unsettling is how consequential these unseen regions may be. Extreme environments are often where new physics emerges, where familiar rules bend under pressure and reveal deeper structure. By avoiding them, humanity preserves its tools, but at the cost of ignorance about some of the most influential processes shaping cosmic behavior. As missions multiplied and instruments grew more sophisticated, these blind zones did not shrink as expected. In some cases, they expanded as sensitivity increased faster than resilience. The better humanity became at seeing the faint, the more it had to avoid the intense. The region space telescopes avoid is not empty or irrelevant. It is a reminder that exploration is constrained not just by curiosity, but by survival, and that some of the universe's most important stories may be unfolding exactly where we cannot yet afford to look. As scientists mapped these observational blind zones, concern grew over what might be happening beyond the edges of safe measurement, because history has shown that extreme environments often drive the most profound discoveries. Regions saturated with intense radiation, gravitational distortion, or overwhelming brightness are not anomalies, but engines of transformation, shaping stars, galaxies, and space-time itself. The challenge lies in exposure. Space telescopes are optimized to collect faint signals over long durations, making them vulnerable to sudden intensity that can saturate detectors, degrade sensors, or permanently scar sensitive components. Looking directly into these regions is not an act of bravery, but calculated risk that could end a mission prematurely, silencing years of planned observation. As a result, avoidance became policy. Software masks, mechanical shutters, and pointing restrictions were implemented to protect instruments from harm. Over time, these safety measures hardened into accepted boundaries, defining where telescopes could and could not look. The universe within those boundaries became well characterized, while everything beyond remained partially invisible. What unsettled researchers was how much influence these avoided regions exerted on the surrounding cosmos. Energy, matter, and radiation flow outward from them, shaping environments that telescopes can observe indirectly. Effects are measured without seeing causes, forcing scientists to reconstruct reality from shadows and consequences rather than direct evidence. Attempts to observe safely through indirect means reveal limitations. Reflected light, secondary emissions, and gravitational signatures provided hints, but not clarity. Each method filled in pieces of the puzzle, while leaving core questions unanswered. The heart of these regions remained inaccessible, protected by the same forces that made them important. As technology advanced, a paradox emerged. The more sensitive telescopes became, the more fragile they grew, and the larger the regions they were forced to avoid. Progress in seeing the faint came at the cost of blindness to the intense, reinforcing the idea that understanding the universe requires not just better instruments, but new ways of enduring its extremes. The conflict sharpened as scientists confronted the consequences of building instruments that could only survive by looking away, because every avoided region represented a deliberate gap in knowledge rather than an accidental one. These were not places humanity failed to reach, but places it consciously chose not to examine, accepting ignorance as the price of preservation. This choice created a structural tension in astronomy. The most extreme environments are often where fundamental physics is tested, where matter, energy, and space-time interact at limits that reveal hidden rules. By shielding telescopes from these regions, science protected its tools while postponing answers to some of its most important questions. Observation advanced, but selectively, researchers debated whether this trade-off was sustainable. Some argued that indirect measurement was sufficient, that consequences observed at safe distances could be modeled backward to reveal causes. Others countered that inference without direct observation risks reinforcing assumptions, turning blind zones into echo chambers where theory feeds itself without challenge. The difficulty was not simply technical, but philosophical. Exploration traditionally means exposure, yet modern astronomy had inverted that relationship, favoring longevity over immediacy. Telescopes were built to last decades, but at the cost of avoiding moments of intensity that might reveal something transformative in seconds. As discussions deepened, the blind regions took on symbolic weight. They represented the boundary where curiosity meets vulnerability, and where the desire to know collides with the risk of losing the ability to know anything at all. Science was no longer limited by imagination or distance, but by fragility. In that realization lay the heart of the conflict. Humanity had reached a point where it could see almost everything faint and distant, yet remained powerless before what was close, bright, and extreme. The universe was not hiding these regions. We were choosing not to look. The climax of this story arrived with the recognition that avoiding these regions was not a permanent solution, but a temporary compromise, because the unanswered questions they contain continue to shape everything that could be safely observed. The blind zones were influencing cosmic behavior from behind a curtain, and understanding their effects without seeing their source began to feel increasingly insufficient. This realization pushed astronomy toward a new phase of design. Rather than building ever more sensitive instruments that required greater caution, researchers began exploring resilience, creating telescopes capable of enduring extremes rather than retreating from them. The goal shifted from perfect clarity to survivable exposure, accepting partial damage as a trade for unprecedented insight. The resolution did not eliminate blind regions overnight, but it reframed them as challenges rather than limits. Observatories were planned with layered approaches, combining robust instruments for intense environments with delicate sensors for faint signals, allowing science to approach danger gradually rather than avoid it entirely. Curiosity regained ground once ceded to fragility. On a deeper level, the story revealed something essential about exploration itself. Knowledge does not advance only by refinement, but by risk, and the willingness to accept loss in pursuit of understanding. The regions space telescopes avoid exist not because they are unknowable, but because humanity has not yet decided how much it is willing to sacrifice to know them. Today, those regions remain partially hidden, but no longer ignored. They stand as reminders that the universe does not yield its most important secrets gently, and that seeing everything may require accepting that some discoveries come at cost. So what do you think? How much risk is worth taking to understand what lies where we are afraid to look? The